All right, guys, welcome to lesson 7. All right, in this one, we just talked about linear equations and stuff like that. Now we're going to talk about other types of equations. The first one we're going to talk about is polynomial equations. All right, so we're just solving for x. That's all we're doing here. All right, but we're going to get everything to the same side. So we got 3x to the fourth minus 27x squared equals 0. Take out a GCF, so both terms have a 3 in common and an x squared in common, so I can take out 3x squared, and that's going to leave me with x squared minus 9 equals 0. And then you can set each one equal to 0. So you got 3x squared equals 0, x squared minus 9 equals 0. And so you divide by 3, you get x squared equals 0. So that means x equals 0. X squared equals 9, so x equals plus or minus 3. And so that's your answer, 0 and plus or minus 3. Same thing on number 2. We have 4x to the fourth minus 12x squared equals 0. Take out a 4x squared. You got x squared minus 3. All right, so that gives you 0. So we have 4x squared equals 0. X squared minus 3 equals 0. X squared equals 0. X equals 0. X squared equals 3. X equals plus or minus square root of 3. Okay, so that's that. When we get to 3 and 4, we have 4 terms that we need to get all on the same side. So we got x cubed plus x squared minus 4x minus 4 equals 0. And because we got 4 terms, we're going to factor by grouping. All right, so we're going to pull out an x squared, and that's going to leave us with x plus 1. We're going to pull out a negative 4, which is going to give us x plus 1. Now, both terms have an x plus 1 in common, so I'm going to pull that out front and put the other pieces together. So you got x plus 1 and x squared minus 4 equals 0. Set them both equal to 0. X squared minus 4 equals 0. So x equals negative 1. X squared equals 4. X squared equals plus or minus 2. So nothing to it. Just make sure everything's on the same side, and then do what you need to do. 3x squared minus 8x minus 12 equals 0. All right, once again, factor by grouping. So we got, pull out an x squared, and that's going to leave me with 2x plus 3. And we'll pull out a negative 4, which is going to leave me with 2x plus 3 equals 0. Both terms have a 2x plus 3, so I'm going to pull it out and put the remaining pieces together. This is going to be x squared minus 4. So then both equal to 0. So you got 2x equals negative 3. X equals negative 3 halves. X squared equals 4. X equals plus or minus 2. All right, the next one we're going to talk about is radical equations. All right, and these can be a bit tricky, so let's take a look at this. So extra solutions may be introduced when you raise both sides of a radical to an even power. Such solutions which are not solutions of the given equation are called extraneous solutions or extraneous roots. Okay, so that's a lot of words, but let's talk about this. All right, so the first thing you want to do is you want to get the radical by itself. Okay, so we got square root of 2x minus 1 equals x minus 2. Now at this point, we're going to get rid of the square root, we got to square both sides. So I'm going to square both sides. Now on the right side, you're squaring a binomial, so that's going to look a little different. This is going to be 2x minus 1 equals x squared minus 4x plus 4. Now get everything to the same side. So we got 0 equals x squared minus 6x plus 5. Factor this. So x x minus 1 and 5 equals 0. So when both equal 0, you get x equals 1 and x equals positive 5. Now that we have finished with the algebra, now we need to check our answers. So I'm going to take 1 and plug it in. So you get 2 times 1 minus 1 plus 2 equals 1. Okay, well that's going to give us 2 minus 1 underneath plus 2 equals 1. 2 minus 1 is 1, so I get square root of 1 plus 2 equals 1. That is 1 plus 2 equals 1, which is 3 equals 1. All right, so when I plugged it back in, it doesn't work, so I throw it out. All right, so let's try 5. Let's see, we got square root of 2. Square root of 2 times 5 minus 1 plus 2 equals 5. All right, 2 times 5 is 10, minus 1 is 9, so I got square root of 9 plus 2 equals 5. Square root of 9 is 3, plus 2 equals 5, so 5 equals 5. That one works. So my answer is x equals 5. And I get to keep the one that works. All right, let's do it again on number 6. Now this one, we have 2 radicals, and right now they're on the same side. So we want to get one radical on one side, one radical on the other. So the one that's negative, 3x plus 1, the one that's negative I'm going to put to the other side. So it's going to be equals square root of x plus 4 plus 1. And from here, I'll square root both sides. I'll square both sides. Let's see. So it's going to be 3x plus 1 equals, I'm going to square my first term, so it's going to be x plus 4. And I'll multiply my terms together and double it, so it's going to be 2 square root of x plus 4. All right, plus 1. All right, now we need to get that second radical by itself. Okay, so that's going to be 2x plus 1 equals 5 plus 2 square root of x plus 4. Subtract the 5, you get 2x minus 4 equals 2 square root of x plus 4. Now I'm going to divide by 2, and so it's going to be x minus 2 equals square root of x plus 4. And then here I'm going to do what I did at the beginning. I'm going to square both sides to get rid of that radical. All right, so it's going to be x squared minus 4x plus 4 equals x plus 4. Get everything to the same side, so you got x squared. That's going to be minus 5x. And that's going to be, that's it. So because I only have the 2 terms, I look at both. There's an x I can take out, so I got x and x minus 5. I still set both equal to 0, but the first one is just going to be really simple. It's x equals 0, and then x minus 5 equals 0. And so you got x equals 5. Well, once again, I got to plug these into my original and see which one or both work. Okay, so I got square root of 3 times 0 plus 1 minus, let's see, 0 plus 4 equals 1. All right, 3 times 0 is 0 plus 1, so I got square root of 1 minus square root of 4 equals 1. So that's going to be 1 minus 2. All right, that's negative 1, so that doesn't work. All right, let's try 5. So I got square root 3 times 5 plus 1 minus square root of 5 plus 4 equals 1. 3 times 5 is 15 plus 1 is 16, so I got square root of 16 minus the square root of 9 equals 1. Square root of 16 is 4 minus 3 equals 1. 1 equals 1. So that one works. And so I get to keep x equals 5. All right. So equations with rational exponents. So we can do this something similar with these, but here's what we got going on. When you raise the power to the power, you multiply. So if you have a fractional exponent, you just you raise it to the reciprocal. Okay, so as you can see right here, I'm going to multiply m over n by n over m, and that's going to get rid of the exponent. But whatever you do to one side, you do to the other. Okay, and if the power is even, then you have to do the plus or minus. If it's odd, you don't. All right, so let's get started. So the first thing I'm going to do is I'm going to get 6 to the other side. So it's going to be 3 x to the 3/4 equals 6. Divide by 3, you get 2 equals 2. And then from here, I'm going to raise both sides to the 4/3. And that's going to leave me with just x on the left. Okay, so 2 to the 4/3 would be my answer. Okay? All right, on number 8, I got x to the 2/3 equals, you got -1/2 plus 3/4. So when you do that, using your calculator, you're going to find that that is 1/4. And so I'm going to raise this to 3/2. All right, and because the denominator is 2, then I'm going to, since the denominator is 2, I got to consider the plus and minus of this. So this is going to be x equals the plus or minus of, so this is going to be 1/4, square root of 1/4 to the 3rd power. All right, the square root of 1/4 is 1/2. So x equals plus or minus 1/2 to the 3rd power. So x equals plus or minus 1/8. All right. Same thing on 9. 5x 3/2 minus or equals 25. X to the 3/2 equals 5. I'm going to raise both sides to the 2/3. All right, so x, because the denominator is odd, I don't have to worry about the plus or minus. So 5 to the 2/3 is my answer. Now, I was able to solve 8, but I was not able to solve 7 or 9, and that's because it's hard to take the cube root. The 2 is not a perfect cube, and 5 is not a perfect cube. And squaring them or raising them to the 4th doesn't give you a perfect cubed. So if you're just going to get a decimal for your answer, you might as well just leave it in exact form like this. All right, so last one in this section. So you got x to 2/3 equals positive 4. So I'm going to raise both sides to the 3/2. And since the denominator is even, I got to consider the positive and the negative. So I got x equals plus or minus the square root of 4 to the 3rd power. Square root of 4 is 2. So you got x equals plus or minus 2 to the 3rd power. And that is 8. So plus or minus 8. All right. Now, on number 11, this can be a little complicated. All right, so first of all, a lot of students freak out when they see a trinomial like this that is raised to the 4th power and then the middle term is squared. I promise you, it's not that difficult. We talked about in a previous lesson that if it's raised to an even power, you're just splitting it in half. So the x to the 4th is going to break down to x squared and x squared. My second sign is positive, so I got plus and minus. And then what are the factors of 9 that subtract to give you 8? Well, that would be 9 and 1. And since the middle term is negative, it's going to be 9, minus 9 and plus 1. Okay, so x squared plus 1, there's nothing I can do with that. So I'll break it down. X squared minus 9 is the difference of 2 squares, which will factor into x plus 3, x minus 3. And so you say each of these equal to 0. All right, and so you get x squared equals -1. X equals the square root of -1 is I, but because I took the square root, I gotta say plus or minus I, and then this is gonna be x equals -3 and x equals 3. All right, and so I have all those are my solutions. Now on 12, you have fractional exponents. All right, so here's what we're going to do. We're going to kind of, some may say cheat, all right, but we're going to get creative here. I'm going to get creative and use u substitution. So here's what that means. I'm going to let u be x to the 1/3. All right, so if I do that, that means this is 5u squared plus 11u plus 2. Now, this looks very similar to what I've done before, and that's where the creative part comes in. All right, I've got to use the AC method, so I'm going to take the 5 and throw it to the back. So that's going to be u squared plus 11u plus 10 equals 0. All right, so that's going to be u plus factors of 10 that multiply to 1 or 10 or multiply to 10 and add to 11. So it's going to be 1 and 10. Because I started with 5, I got to divide by 5. Okay, so this is going to be u plus 1/5 and u plus 2. Any remainder that's left, I'm going to throw it in front of the variable. I got 5u plus 1, u plus 2 equals 0. All right, now I need to set each of these equal to 0. So 5u plus 1 equals 0, u plus 2 equals 0. All right, so it's going to be 5u equals -1, u equals -1/5, u equals -2. Now, we also said that u was x to the 1/3. So here's what we're going to do. We're going to take each of these and say x to the 1/3 equals -1/5. And x to the 1/3 equals -2. And just like we did before, I'm going to raise both of these. I'm going to cube both of these to get my answer. All right, so that's going to be x equals -1 over 125. And that's going to be x equals -8. And there you go. We can also use substitution on like number 13. In this situation, I'm going to let u be x squared minus 5, which allows me to write this as u squared plus 3u minus 10 equals 0, which is easily factorable. So you got u plus minus. All right, 5 and 2 multiply to 10 and subtract to give you 3, so it's going to be plus 5 minus 2. And I know it's plus 5 because the middle term is positive, so the higher factor gets that sign. All right, so I got u plus 5 equals 0, u minus 2, or yeah, u minus 2 equals 0. All right, so u equals -5, u equals 2. All right, so x squared minus 5 equals -5, x squared minus 5 equals 2. All right, so you got x squared equals equals 0, and you got x squared equals 7. Okay, so take square root of both sides. Because it's 0, I just get 0. X squared I take square root of both sides, you get x equals plus or minus the square root of 7. All right. Now, absolute values. The thing about absolute values is its distance from 0. Distance is a unit of measurement, and like any other measurement, like time or length or width, it can't be negative. All right, so distance can't be negative, so no matter what I plug in to the absolute value, no matter what I plug in for x, it's going to spit out a positive number. Okay, but what I plug in could result in a negative number, so I have to consider both cases. So once I apply the absolute value, the answer becomes positive, but the inside could be positive or negative before I'm done. So what I'm going to do here is I'm going to drop the absolute value and say 2x minus 3 equals 11. But I also need to consider the case where 2x minus 3 equals -11. And again, this is before the absolute value is applied, but because the absolute value equals 11, I have to consider the inside to be positive and -11. And then you just solve each of these. So you got 2x equals 14, x equals 7. You got 2x equals -8. x equals negative 4. And so to get 11, I can plug in 7 or I can plug in negative 4, and it gets me the right answer. All right, so do the same thing on 15. So you got 2x minus 1 equals 5, or 2x minus 1 equals negative 5. So you got 2x equals 6, x equals 3, 2x equals negative 4, x equals negative 2. All right. Before you can do what we just did on 14 and 15, you have to get the absolute value by itself. So on 16, we got 5, 1 minus 4x equals positive 15, and then divide by 5. So you got 1 minus 4x inside equals 3. And now I can do what I just did. So I got 1 minus 4x equals 3, or 1 minus 4x equals negative 3. All right, so we got negative 4x equals 2, x equals negative 1/2, negative 4x equals negative 4, x equals positive 1. Okay, so just like that. Last one in this section. All right, so get the absolute value by itself. Equals positive 20. The absolute value equals 5. So 1 minus 2x equals positive 5, or 1 minus 2x equals negative 5. All right, well, I got negative 2x equals 4, x equals negative 2, negative 2x equals negative 6, x equals 3, positive 3. All right. All right, guys, that's it for this lesson. I'll see you in the next one.